Okay, so thanks everybody for coming. That's a really cool turnout, and I'm excited to see so many people here because this is a really, really cool talk. And I'm glad everybody's listening to my massive pushes to get y'all here. So it's the Utah Go user group. I'm gonna do a quick notice up front, especially because there's a lot of new people here in the room. Microphones are really, really good. You can't see them, they're all over, and they will find you and zoom in on you if you're whispering or anything. So we'll do our best to edit it out, but just be aware, like, you might think you're being really quiet, and you are. The microphones are better than picking you up than you think. There's all these links here at the bottom. I always specifically point out Slack, because that's where all the sass and good conversation is, and the random channel is pretty great if you want to just keep up on all sorts of stuff happening around here and elsewhere in the industry. Also, specifically, there are channels dedicated to hiring people or finding jobs. If you want to post in either of those, that's fantastic. Just invite everybody to come on to the Slack because it's great. If you want to speak at this meetup, we are full out November and December. We've got people, but I'm wide open starting the new year. So we typically actually do come in for a January meetup pretty early after the new year. It's the first, I don't know what exact date it is, the first Tuesday in January. So I'd love to have as full of a start of next year as I've had a full of the end of this year. If you want to submit, you just go to paper call. It'll say Women Who Go Utah, but it's kind of shared between, we've merged those a while back. So it's really that one paper call for this meetup and it's kind of shared in that one as well. Very, very soon we have Go West. So I don't know, October 21st, it's going to be here at Weave. I normally have Mariah here. Oh wait, Derek, are there tickets? For Weave? For coming to Go West in person? Okay. There's still tickets. So it's really fantastic. I know that we just bought our drink package. So if you stick around for the after party, we've got drinks. You can also, I guess, learn about Go before the after party if you want.
We all know what you're really here for.
Yeah, we all know what we're here for.
Don't let her in.
And that is October 21st, again, here at Weave. And you can get that at gowestconf.com. And that's it. That's all I'm going to do. I'm going to hand everything off to Shubham. I want to say real quick, I put him down and he must really, really want to speak to us because twice I did not communicate specifically enough. So he got up at 5 a.m. his time yesterday to speak to you because I miscommunicated the time zone day difference. And then he got up again today to talk to us about this. I've seen this before at Open Source Summit and it was fantastic. And I got a preview when I chat with him yesterday when I accidentally made him get up early. There's even more new stuff. I don't know if it's in this or if he'll just touch on it, but this is a really, really cool project. And I'm really excited to have him coming and trust you. So I'm going to hand it over to you, Shubham.
Thanks, Carson. And yeah, I mean, the time zone mixing was mostly on me. But yeah, thanks.
If you do us a favor, sorry, when I took over, it made your share minimal. So if you'll stop sharing and reshare just so it takes up the full size on our screen. And then, then we're good. Otherwise, it'll be really hard for us to see your slides.
Yeah, no problem.
There it is. Perfect. Thank you.
Perfect. Yep. So yeah, I'll before introducing Keploy, we'll quickly walk through our journey and the problem that we're trying to solve. So Keploy, I mean, Neha and I are the maintainers of Keploy. We have been part of the data engineering and the office of CTO at Farai. Farai is a logistics SaaS company in India. We've had a similar role at Lenskart, which is an e-commerce eyewear retailer in India, similar to Warby Parker. And yeah, we've been quite active in the open source world. We got introduced via Google Summer of Code, and yeah, have been active ever since. So in our roles, we were part of the office of CTO kind of profile, and so we were independent of the core product team, and we had to try out new things for the business, and that meant that while the rest of the teams had a dedicated QA process, we did not have one because we wanted to move fast. And so we definitely had strict timelines. We wanted to experiment, um, release almost on a daily basis. So that was, a big important factor for us. Yeah, we didn't have a dedicated QA team. Timelines were short. We were doing a lot of experiments. So yeah, we had very limited time that we could spend on testing. And yeah, we broke a lot of things. So there were regressions, but um, I mean, being companies at that scale, basically Indian unicorns, there was still an expectation of stability even from experiments, especially once those experiments start to scale. So we had those. I mean, I'm sure all of you have these constraints, but it was especially highlighted compared to other teams within our own company. So um, essentially, to reduce these bugs and to reduce frustration to our customers, we wanted to ensure that we have more realistic functional tests. Um, in fact, a few days ago, we were integrating with, just talking to one of our users and helping them debug a problem, and they were integrating the Keploy SDK. And that's when we discovered that um, many of the parameters, like they had refactored their whole code base along with their unit tests, and many of those parameters were not actually doing anything. So many of those config variables were only used in tests, and they were not even handled in the actual functions or methods. So um, we wanted to have more realistic functional tests. It has many advantages. They have to be easy to create and update. I mean, as less of an effort as possible. Like in the ideal world, uh, as a developer, I should not need to write those tests. But yeah, as close to that as possible. And yeah, the hardest part that we have seen, or which we think is about testing, is the infrastructure and the test data. Like ensuring that one, you either have really good, high quality, infrastructure mocks or infrastructure along with realistic data. So that I think has been the most difficult part of ensuring that you have a usable testing setup, which I mean, I'm sure while writing unit tests or your testing pipelines, you would have probably dealt a lot with. So yeah, I mean, those are things that got us started, and we're still trying to ensure we're able to deliver to this day. So I'll quickly walk through a bunch of solutions that we tried. So one was definitely writing test cases as usual, and as I mentioned, one, they were time consuming. Two, they can often be very brittle. So, um, I mean, yeah, the standard classical approach, and we wanted, I mean, we knew we can do something better, right? So, um, other common problem is also, like I mentioned, synthetic tests, synthetic mocks, uh, which often can be very different. And another problem which many of you might have seen is when you use real environments and they're shared, uh, people mess around with those environments and they might break something which you might be doing. So those shared environments can also be a big pain. So I mean, you know we started with testing in production, and initially it sounded crazy, but um, yeah, I mean, it turns out it has a lot of merit. So we went deeper into the different ways around how people test in production. So yeah, the first and obvious thing is shadow testing. I mean, that's basically generally how it works. So here, essentially, what happens is, let's say you have one application version, and you are going to test a new version. People basically duplicate traffic. So in today's world, you could just use some traffic mirroring proxy or service mesh, and yeah, that should do it for you. This uh, this works great if your application is stateless, right? So if you don't have state, this generally works fine. But what happens when you have dependency? Like you have a database, or you have services, um, or you have all the side effects that can happen from um, mirroring that data. What happens there? So uh, there were a bunch of ways to handle that. Um, One was definitely connect the same database. I've seen a lot of you know articles and resources online about this. The obvious downside of this are the side effects. There are idempotency guarantees, which has to be there, else you're going to corrupt something, or we're going to have a lot of side effects. So yeah, I mean, this one is pretty obvious. So the second thing was, let's just filter out the reads, and go and only allow that downstream. So we would not be doing any mutations, any writes, to ensure that we're not corrupting anything and not having unnecessary side effects. So that reduces side effects, but then we're not able to test a big chunk or important components of our system. So yeah, there were downsides, but I still found some people doing this. Um, so yeah, it was an interesting approach. And then there was one other interesting approach where people started creating replicas, right? So you have two different databases, but then we have replicas, and those replicas are synced, um, similar to how we have typical database replicas. This is a relatively more complex setup. There are obvious problems around. Yeah, it's going to be expensive because you have to have all that thing. Um, there would be replication lag, which can make your tests flaky and unreliable. And also, I mean, there are a bunch of other downsides as well, based on how the data really syncs, mismatch in states and stuff like that. So um, again, we were not really satisfied with this approach, so we move further. So I mean, then it occurred to us, we were trying to test online, like as the traffic was coming, but we didn't have to do that. So we're like, okay, how about, instead of testing online, how about we save those tests and test it later? Because we I mean, we are fine if those tests run later in time, somewhere in a CI pipeline. They don't really need to serve the traffic right there in production. Um, so yeah, we essentially took that same approach, and instead of having that real replica, we took a snapshot at that state in time, and in a non-production or in a CI environments, we would create databases right from that exact same timestamp, and mirror the traffic. So we did this for quite some time, and it worked really well. The obvious merits are that um, you know this is more consistent. We were able to uh, get more reliable tests and all of that. But yeah, it's definitely a big operational effort, because you have to ensure that you have that pipeline which, on a daily, weekly, or some time frame, is able to take snapshots and use snapshots as well as your traffic data, and use that in your CI pipeline. And since we had a lot of microservices, this became harder and harder to do, and to ensure it's consistent across the whole set of services. But yeah, this worked for quite a while. And although there's massive operational effort, it was sometimes brittle, it was expensive, but it worked. So we had the most success with that approach so far. Now, so far, like, if I had to have a summary of the approaches we have had, these are fairly low code approaches, because we're not writing code. uh, all that we would write is in all that code to do the operational part. It's easy to achieve high coverage, because I mean, it's production. So if you've written code which executes in production, it's easy to ensure that you have high test coverage. It can unlock unexpected user flows, because again, it's production data. And cons, yeah, this can cause flakiness, especially in a microservice environment. Um, uh, with the last approach, we reduce it as much as possible, but there's still chances. Um, these work really well for load and stress testing, because you have all this huge amount of test cases that you can run. But for functional testing, it often got very frustrating, because now instead of maybe 50 or 100 or 200 tests, you have like millions of requests. And when something fails, you would have thousands or hundreds of thousands of failures. So it's really hard to go into each one of them and debug that. So that created a bit of problems for us. Handling writes again can be tricky. We saw the last approach, which worked for, but for the other approaches, handling writes is tricky. Um, so what we thought of then was, like, from the previous approach, we worked further, and what we realized was this shadow database doesn't really need to be a real database. Like, essentially, for the application, um, as long as I can make the application think that for the database queries or API calls, I'm returning what the database would actually return. It should be fine. So that's what we went essentially mocking, right? So essentially, we create a fake or a virtual database, which is not real database. So let's say you have a 10 terabyte database. Now you don't have to have that snapshot being done daily. Instead, we record all the database interactions and replay that kind of. I mean, so that um, ensures that we don't have to have the same exact state in the database. It highly reduced the amount of data that we need to have, and yeah, it made things far more reliable. Obviously, uh, replicating the runtime characteristics of a database, like the latencies and connection timeouts, this becomes harder. But from a functional test perspective, similar to what we do in a unit test, it's essentially mocking. So we record those transactions and basically create mocks. So yeah, that worked really well. So for example, let's say in our production environment, we had there's an API get gains, and you had a user Thompson, that goes to the application, and maybe using MongoDB. Um, Now there are bunch of this bunch of data. There the application would query for these two tables and return the relevant data. Now in my test environment, um, when I try to do this, user Thompson itself might not exist. If there's any problem with the snapshots or the way we are orchestrating a database. However, if instead of replicating the whole database, we just uh, replicate the response of the query. Now I don't have to maintain a whole database. I don't have to maintain that huge data snapshots. I can just return that same exact response, and the application would behave as it is. So application would not know that I don't really have a real database. So yeah, like I said, it's basically mocking. So yeah, that's the approach. Um, so what we ended up building, I mean, we summarize all of this into Keploy, which is an open source platform, a toolkit, and what it basically does is that similar to your observability tools like Datadog or New Relic, you can add the instrumentation SDK to the application, um, and instead of just observability, it would record actual transactions, um, and you can save it. You can save those interactions into a file or into a database. Uh, Earlier, we only supported database, but from a lot of user feedback, and we ourselves also use Keploy to test Keploy. So we realized that having those tests in a readable format in a file has a lot of value. So that's what Keploy does today. We still have a database component for the test result history, but that's also being removed. So it should be removed in about a week or two. So what happens is, uh, all the interactions. Like if you have an API, you can record all the interactions you're having. You can do it locally, or you can record from an environment. Uh, those request response gets captured. All the dependencies, they get captured and they're saved to a file, which you can edit. In case of HTTP traffic, if it's, let's say, a database query, it's not editable at the moment. Um, but yeah, it's saved to a file, and you can version control, or you can also keep it in Keploy's database, and host it, in your own infrastructure. All of those work. Um, and yeah, you can rerun those tests, and Kepler will automatically mock, the right data for that particular test, which you can also edit and play around. Something that also we added recently is, if you want to use your own testing library, right? Your own testing framework, and you want to use Keploy only for mocking. So now Keploy also has an independent mocking library where you can capture anything. So let's say you're an SDK developer, you're not writing an API at all, or you're writing an API, but you want to use a different testing platform. So you can capture database queries and save that to a file, and then reuse them wherever you want. So it could be database queries or API calls. Also, something cool which we recently did was, for HTTP test, like as a server developer, um, the HTTP test is basically request and response, and maybe some dependencies. But uh, it's also the same for mocks. So that's the same thing for an HTTP mock as well. So if you're a server developer, you can share your tests with your clients, and they can use it as mocks, right? And also vice versa. So a client which maybe created a mock by calling your real API and then storing it into a file and using it as a mock in their tests, they can share that with you, and you can use that as a test. So that's also something we recently did. I'll be showing that in a bit. So yeah, that's quickly about the architecture. And yeah, I'll now show you a demo. Yes, Matthew. Do you have a question?
Yes. What I wanted to know is, so I was seeing your diagram where you have V1 and V2 running concurrently. What happens if your V2 has evolved the queries that it's running against? So if it goes against a shadow database, it's going to be asking for more or less or different data than V1 would. How does that work when you use the shadow database?
Yeah, in that case, because it's not a real database, you'd have to create new responses. So you'll have to discard the old ones and recapture the result of those new queries.
Okay, that makes sense.
Perfect. Thank you. Yeah. So the example that I'm about to show you, it's also available on Keploy samples Go. So Keploy is written in Go, and Go is the first language that we also supported. It's the Echo SQL. So we're using the Echo router, and I think it's Postgres. Yeah, it's Postgres. So I mean, it's a simple URL shortener. It's a CRUD API. You can give it a sample URL. It would generate a shortened URL for you, and can get it back, edit it, all that stuff. So I currently have that in Golang. Let me also bring my terminal. Yeah. So as I said, Mongo is going to become an optional dependency. Right now, it's only used for storing the test run history, like your all the previous history of the tests that you've run. So for now, we still need it later. We're now working on writing all of this to a file wherever you run it, and it obviously logs the information, but yeah, also in a file whenever you need it. So we have to start a Mongo, and then Keploy. So yeah, Keploy is up. And for this particular application, as you can see, we have to start Postgres because this sample application uses Postgres. So let's do that. Postgres is up. And okay, so this is already running. Or was it? Yeah. And yeah, we're in the application. So the URL shortener is running. Now, to use it, in fact, Keploy also has a UI, but we are now making it more CLI first. So I think Keploy is up, yeah. So we can just copy paste. So we are doing it for github.com. So as you can see right now, I don't have any test folder or any Keploy test folder. The integration that I had to do was similar to what you would do with any instrumentation SDK. So you initialize Keploy, you can give it a name like your application name. This would show up in your test runs, or if you use the UI, and yeah, and the port of your application where it would this would be used during testing. Um, and yeah, and then you have to just wrap. So we have this Echo middleware similar to that. We have a Postgres wrapper. So you just wrap your Postgres client. Yeah, this is where that happens. And yeah, that's it. So go run. Oh wait, I already done that. I have to do a curl. Yeah. So as you can see, I have a timestamp and I have a URL. This is the shortened URL. So I can also run this. Use this URL. In fact, as I did this with the first test itself, you can see that there's one test generated. It looks similar to a Kubernetes manifest, but it's not a CRD yet. So you can install it on Kubernetes, but it gives it a random name. You can override this. You can change the name of the file. And yeah, there's a metadata field. You have your request. So this is the request that we send. You have the response. All of these fields can be edited. Like you can version control it in your code base, and you can edit these. And then you have a bunch of mocks. So these are the different Postgres transactions that happen. And yeah, this is an interesting field. You have noise, right? So here we have a block for assertions. What we're also trying to do is provide Keploy's library to write assertions manually if you want to, right? By right now, it's just going to compare the same thing or not compare it. So anything that's in the noise will not be compared, and rest fields will be compared. Basically, they will be asserted. What we are planning to also work on is similar to K6, like allow people to write custom assertions in their own code by importing this file or any of these. And yeah, the created timestamp of this. So what Keploy also does is it issues a duplicate request. During the duplicate request, it would mock all the dependencies, and it would check for responses if there are any difference. So things like timestamp or this non-deterministic fields, they would be flagged and automatically added as noise, which again you can change. I mean, there could be a false positive or a false negative, so you can edit these. But yeah, this body.timestamp is what it thinks is a noise level, which is right for now. And yeah, now I'll do the get. So that has happened as well. And as you can see, there are these mode tests generated, and these mocks, you can also go and see those. So these are two mock files. These are different Postgres transactions. So first there was an operation ping, and then query context for this particular query. Then query context for columns, and then next, and all this bunch of stuff, execute context. So these are all these Postgres calls. This for now, like this is binary data, right? Base64 binary data. So this is not editable. But if this was an HTTP call, so the mock for that would be editable, but not yet for HTTP, for SQL. We're working on making this editable as well. But for now, it's not editable. And yeah, so we have these bunch of files. Now we can run these as tests. And to do that, we can just use go test. So in your go test file, you can have a method, and in this case, I'm just setting a different port for the test. Um, but yeah, basically just set Keploy to test mode, run your application, and then assert these tests. That's basically how it works. So in fact, let me stop this. I also don't need my database, since it's mocked. And yeah, I can run these tests. Yeah, so as we can see, these tests have passed. I can also go to the Keploy binary and see, okay, test run started, uh, all fine for now. And yeah, we have 51% coverage, based on this. It's a small little uh, two-file code base. Now, what happens if, and yeah, you can also see this on the Keploy UI. Um, so yeah, so there's a UI as well. Um, Now, if I make a change, right? It could be either to um, let's say my data structure for this application. So let's say instead of URL, I'm going to have URLs. That's a change, and yeah, I can run these tests. So I can go to go test. Now, yeah, as you can see, one of the test case failed. We also get console output around the diff, what was expected versus what was received. So um, it's basically the URL field. You can also see this in the UI. So we go here, like a UI based diff, and yeah, we can update that in the tests if we want to. So post and change this to URLs, and you're good. And we in the UI we also have a normalize button, which again would do the same thing. But yeah, I'm doing it from file for now, and then just rerun these tests. Now, although this block which is running the Keploy tests, reading from all those files and running these tests, um, I mean it's this is basically an end-to-end test. It's an API test, and you can use this along with your testing framework. But how we use it nowadays is, so by the way, tests have passed because we have updated it. And so, I mean, since I'm able to see test coverage, I can either capture from an environment or locally create test cases, so that I have more coverage. For example, here I have extra methods like delete and update. I can do that. But in many cases, having unit test is still good because there would be deeper methods which are easier to test via unit testing those methods specifically. And how we use Kepler nowadays is that we have bunch of this E2E tests, and we use unit tests to test those critical methods or those deeper methods, which are easier to test as unit tests. So basically we have choice, and then since all of this works along with GoTest, you have a combined coverage. So you're able to see blind spots, and then uh, you know we're able to choose which one suits better. Do I write a unit test for that, or I can create an API test? Um, Now to again show the mocking capabilities, show another example. So I've picked this example from um, from a blog where you have, I mean, there's a simple file which is fetching data, a simple struct, and it's doing it, initializing an HTTP client, and uh, you know doing a simple HTTP request. Now, typically, if I'm going to unit test this particular file, I would have to, um, you know, create a test main where I will create a, a mock HTTP server, and then a mock endpoint, right? Um, and write the mock response that I want, and then also create this mock data, right? Um, so this is what we would typically do to unit test this particular thing. But with Keploy, what we can do is uh, we Keploy has this mocking library, so this is where that gets important, and we just wrap the HTTP client. So this is where that happens, right? So basically, I can set this as record, and as you can see, I already have a mock folder. I'll delete this, and all of these folder names can be overridden. There are a bunch of config. It takes, uh, we have some defaults for the paths and file names, but yeah, all of that can be overridden, and uh, we can set it to record mode and just run this test as it is. In practice, you would want to run this against your real API, but since we have mock, and just for demonstration, I'll run it against the mocks that have been written here. So as you can see, the tests have run, and um, wait a minute, this should have. Oh, okay, got it. I'm using the older version of SDK. Yeah, we made a bunch of changes. Yep. So, 1 minute. Oh, perfect. As you can see, um, you know, using logs from Keploy that they've captured this, all of that. And if I go back, I can see these two mocks being generated. Now, this is the same file as the HTTP test. So if I was the author of this particular server, which I'm trying to mock, I could have just shared the test with the clients. And in this case, I'm the customer, so I'm creating these mocks from my as an HTTP client. I can also share these with the author, um, and they can use this as a test. So it's the same file, it's the same exact file, and yeah. And now, since I've already captured these, I can change this from mode record to mode test. And now I don't need to have all of these mock stuff that I've written. So we can mock, remove all that. So this is no longer needed. Oh, wait. Um, this is also no longer, okay. So some things are needed. We don't need the mock server. We don't need, yeah, so we remove the mock server. We also don't need these test cases. Or wait. Oh yeah, so we would need this because here we have the assertions that we've written. And okay, so we need this as well. Yeah, stuff related to the mock is what we don't need. And same with, so this is the test case, so I don't need that. Okay, I think we're good. So yeah, we remove the stuff related to the mocks, so that is not needed. One of the variables here was needed. Okay, and now I can run these. And if I look at the logs now, Okay, 1 minute. 63. Mm, so there's a null pointer here. I remove something which I wasn't supposed to. External server.url client. Okay.
Server.url won't work because you didn't make server.
Yeah. So I have to server.url. Okay. I don't need this server.url anymore. So
Okay.
let me just keep it this. I think that should work. Yep. So as you can see, return mock output for this, and you can see what that mock was, and same here. So both these were mocked automatically. You can also see some logs here. So mock successfully written, mocks are read from that file, and yeah. So you don't have to explicitly write all of these, um, and you can reuse the YAML files where you want to. So here, there's this for loop, and we're accessing it from the mock name, right? Um, the name that's here. So yeah, that's basically how this works. Um, so yep, I'm done with the demo. Um, and yeah, let's quickly conclude. Mm, yeah, perfect. Oh yeah, so I think that's it for today. Uh, Thanks everyone, and happy to take questions or any feedback. Thank you.
I, Shubham, I had a question. I guess the camera's over here. Hi, Shubham.
Yep.
Uh,
Hi.
The, so can you talk to me about recording production traffic? Can you talk to me about the process or the performance impact to services? I can imagine if we are injecting a middleware and it's run on every request, then I would think that it would get pretty expensive. But can you talk about that?
Yeah. So with recording production traffic, similar to how New Relic or this other observability tool works, we make it asynchronous. However, uh, we did do. I'm not sure if we have already implemented that, but we had some optimizations like giving users some kind of filter on either some headers or some cookies uh, around which traffic to actually record. So right in the SDK, one, everything is async, so it hardly impacts the actual latency, but obviously there's going to be extra resources needed to run all of that um, in the application, as well as running Keploy itself outside the application. So one, from a performance point of view, you can for example add filters. I mean, if you're going to record all the transaction, it's going to be obviously expensive, because we're not just doing observability but recording the actual request responses and all the infra interactions. So it's expensive. Possible optimization is have filters on what you want to do, maybe a subset of users or something like that. The second thing is, we started with doing production, but one big problem that we faced was maintaining those tests, because those kinds of tests, like I said, are great for load testing or stress testing, but not so much for functional testing, which is where we uncovered most of our problems. So instead of just recording production data, because we need to ensure we have very strong deduplication. That's another work area where we're trying to leverage coverage data to figure out which tests to keep from production and which not, so that we don't have too many redundant tests which are executing the same code path. um, so yeah, I mean, while it's possible, right, and you can use filters to minimize the performance impact, um, maintaining and having a good deduplication or a way to filter out those tests is something that we have not figured out yet. We have ideas in mind, like using coverage data and other stuff, but it's not implemented. So yeah, I think once it is, it'll be pretty awesome to have. But yeah, if you're okay with having thousands or 10,000 tests or maybe 100,000 tests, then yeah, sure, go ahead. Something like that.
Cool.
Thank you.
Anything else?
Who's your target audience for this? Like what's the tech stack or maturity level or size of business, age of business that you're like most valuable to?
I think it would be mid-level companies, or it could be anybody who is writing E2E tests, like especially if they don't have a dedicated QA team, right? So could be large companies. Many large companies are moving to a model where developers are responsible for their tests, and yeah, I think that's where it is. Like, we are not targeting QA developers. It's for the developers of the application. And uh, we know that developers don't talk a lot, especially to each other, especially across teams, right? Not a lot of communication happening. So
Right.
sorry.
No, we were just sneezing, sorry.
Oh yeah, cool. Yeah, so one is definitely the testing part and the mocking part, but it's also around communication, right? We do share API specs, we do share our protofiles, but the behavior gets lost, right? Not many people know what this application is supposed to return, and that might create a lot of problems. So, uh, second aspect around, after the testing and mocking part, is having that common file which you can share, which has the behavior as well as the schema and those stuff. So yeah, it's for developers, especially for developers who are responsible for quality. Uh, and the second subset would be, or the second set of users would be people who are writing mocks for their unit test and they want a better way, right? So yeah, that's kind of where we think this would fit. We're definitely experimenting a bit, but yeah, that's a theory.
I have a question really quick. It seems that with the recording aspect, it seems that you can only generate tests for those things that were seen during the time of recording. Do you guys have any plans to expand the test to include things that have not been seen but are possible?
Yeah, since we have this YAML file, you could theoretically write a test for something which has not happened. So, for example, I could duplicate this file, copy the content, and maybe change the request, maybe add a header, or add some body, or add some extra variable, right? And change the response assertion. So yeah, that should also totally work. Um, the mocking side, you'd have to then add the relevant mocks. So this is actually the mock, but in case of a test, if that test requires a mock, like you want Keploy to also do the mocking right away automatically, so then you just have to reference the right mocks and ensure that you have the right files. So yeah, that way you don't have to actually do them, but you would have essentially tests that can run for things that you can expect to write, right? So I hope that answers the question.
That was great. Thank you.
Thank you.
So how does your team get good coverage without a lot of duplicate coverage? You mentioned that that's difficult using production data.
Yeah, what we do right now is pretty bare bones. What we essentially look for blind spots, similar to how we do for unit tests. And like, for example, in this particular case, I can see that Yeah, the update URL method is not covered at all. So, write something for the update URL. Same for, okay, put URL is kind of covered. I think there's also a delete URL. Yeah, delete URL. So I can see it's also not covered. So yeah, I mean, the same old method, that's what we do right now. But yeah, for production, yeah, we'll have to build something smarter, which can filter out redundant tests. I mean, that's a work in progress.
So you're kind of manually recording or you're recording manual tests, right?
Correct. So we perform them and those get recorded. It's just we don't have to write the mocks and tests right now. I mean, that's how we do it today.
Which is, I think a lot of people, that makes some sense to me because people are like, have big Postman suites for their tests, so they have to have Postman and infrastructure, and this is turn on a mode, run your Postman suite, and then that's your test generated, but in code without Postman required.
Similar to like UI testing.
Yeah. I mean, the goal is like, reducing the effort and also increasing quality. Like in this way, the effort can be reduced like compared to, manually writing those tests, especially the mocking part. And yeah, that should give you more time to think for better test cases, hopefully. And in the future also, enable better production support. So I think that should help more with, more coverage and better tests as well.
Awesome. Well, thank you again. I really appreciate you waking up early twice for us and being willing to come down and speak again. I think this is even just the stuff that you've added since Open Source Summit, like the file-based stuff is really cool. So I'm excited to see where it's going and knew it was a fit for us when it was go first. So one last thing I'll say, when we have people come in person and when I get my RSVPs, I usually order about half the number of people that say they're going to show. And this is the first time where I ordered, I think we had enough food, but I actually underestimated the amount of people that would be here in person. So people have interest and this is really cool. I appreciate you coming and taking some time to get up and talk to us.
Thank you, Carson. I mean, it was really fun presenting here and talking to all of you. I hope you have a great evening. Thanks a lot. And thanks for the questions. Really lovely talking to all of you.